I'm Anil Kumar, and in this video we are going to discuss graph of trigonometric functions with negative angles. The question here is, explain steps to sketch the graph of y equals to sine of minus 2 theta plus 60 degrees, where theta is between 0 to 180 degrees, right? So let us rewrite this equation and try to understand the equation itself. It is sine of minus 2 theta plus 60 degrees. I could factor minus 2 and write the equation as sine of minus 2, and I get theta minus 30 degrees, correct? So that is what I get. Now you know sine of minus theta is minus sine theta, and therefore I could also write this as minus of sine 2 times theta minus 30 degrees, right? So that is how I could actually rewrite this particular function. Now once I have written like this, I can sketch my function with the transformations. So what we notice here is the transformations could be written as, this one is the reflection on x-axis, right? Reflection on x-axis, and that 2 is horizontal compression. So that results into time period change. So time period now is not 360, but it is 360 degrees divided by 2, and that is to say 180 degrees. So one full sine wave will be completed in 180 degrees. Now minus 30 means phase shift, right? So we have phase shift 30 degrees to the right, so it is 30 degrees right, correct? Amplitude remains as 1 since there is no vertical stretch or compression, nor is there any vertical translation, so axis and amplitude, so we know amplitude equals to 1, and we know axis is y equals to 0, the default values, correct? Now with that knowledge, let us sketch the graph of this particular function. So let me use this space to sketch the graph. Now what I will do here is, so we have sine wave whose time period is 180 degrees and which is shifted 30 degrees to the right, reflected on x-axis. Now there is another approach to sketch the same function. You could treat this as reflection on y-axis and sketch on this side. You could do that also, which is also correct, right? So both approaches are correct, but I am using this approach of writing it as a reflection on x-axis and then sketching, correct? So that is how I'm actually sketching my graph at present, but both are correct, okay? Now to sketch the graph, what I will do is, I know the time period is 180. I will sketch it in 2 steps basically. So we'll do 2 steps. Step number 1 will be to sketch the function without phase shift. So I'll sketch y equals to minus sine 2 theta, right? So this is the graph which I will sketch in first step, and then I will sketch y equals to minus sine 2 times theta minus 30 degrees, right? So that is going to be my second step. So in second step, we'll shift the graph by 30 degrees to the right, okay? So the ease of sketching you will soon appreciate when I show you my method of sketching. So what we do here is that we divide the scale into 4 quarters, right? So let me say 4 quarters. 1, so this is first, right? So this is second, and this is third, and this is, let us say, fourth, right? So it is 4 quarters, right? Now I'll take some portion of the graph here also, since we do have a translation, okay? So we divide the this part of the graph in 4 quarters, and we know clearly that 1, 2, 3, 4, that the time period for our graph is 180, right? So starting from 0, and the sine function actually starts from 0, right? Sine function starts from 0. Since it is negative, will not go up but will go down. So instead of 0 maximum 0 minimum 0, we'll go 0, because this is minus minimum 0, maximum 0. You get the point, right? So we get the first part of the graph as such without horizontal translation, right? But we have incorporated reflection in this case. You get the idea, right? Now, so this is the quarter we are saying. So we do have a maximum here. So let me just sketch a part of the graph here also. The reason is we need to shift by 30 degrees to the right later, so we'll do that. Okay, it helps. Now, what we really have is the first part. Now we have to shift by 30 degrees. If you see at the scale, we have 90 and 45 degrees. Now how do I get 30 degrees? To get 30 degrees, I have to divide this into 3 equal parts: 15, 30, 45, 15, 30, 45, 15, 30, 45, 15, 30, 45, 15, 30, 45. So that is where it is going to end, correct? So now we'll translate each point 30 degrees to the right, which is kind of here. Do you see that? So 15, 30. So this point gets translated here, and 30. So that point goes there. This point 15, 30. So it comes right there, and this point ends over there. Now because of this translation, as you can see, I have to translate this point also, let's say 15, 30, 45. So that maximum translates here. Do you see that? So it's good to take this point, since we have to draw the graph between 0 to 180 degrees. Perfect. So what we get here is, so somewhere the point which was at 15 will now come at 0. Do you see that point will be here, right? You can always substitute the values and get the exact. So sine of 60 degrees is what you get here, right? Square root 3 over 2 is what will be the value. Perfect. Now once you have these points, you can join them and sketch the final graph, correct? So the final graph for us between 0 to 180 degrees will be starting from here, right? So let me just sketch kind of like this, starting from here, and okay, so we go from here. So that graph will be kind of okay, so let's sketch this graph. Do you see that? So I'm drawing my dotted line just to indicate that we have to sketch from 0 to 180 degrees. My one wave starting from 0 actually ends there, but since it is kind of 0 to 180 degrees, I will draw like this. Do you see that? So one wave which comes from 0 to 80 degrees is kind of like this. So this is how it is going to be. The maximum is here. This is not the maximum. Okay, so I should have drawn kind of like this, lower, right? Lower than the maximum. So that is how the graph is going to look like. I hope you understand and appreciate the steps. So this is y value for us, and here what we have is theta, right? So theta 90 degrees, 45, 0, and each division here, the small divisions which we worked into dividing 45 was, this is 30 degrees for us, correct? So it actually, one wave starts from 30 degrees and will end at 210 degrees, right? So this point where it ends will be 210 degrees. Do you see that? But that is how you will sketch the graph of the given function easily, right? So I hope that helps. So here in this particular question, we wrote our equation with minus of sine theta to sketch this graph. You can discuss with your teacher about this solution, because some teachers will prefer to you sketch it on the left side of the curve. Anyway, that's all up to you. I hope you understand and appreciate this particular method. Thank you and all the best.